Government Public School. I am your science teacher. We are learning chapter 9, Force and Laws of Motion. Now, today we are going to see the first law of motions, Newton's first law of motion. So, have a look. As what I said yesterday, Galileo did an experiment. In that experiment, he said that on an inclined plane, if you release the ball, right? If you release the ball, it will go down and reaches at the same height, irrespective the angle of inclination for both are same or not. It will reach at the same height, but only and only if it is a frictionless surface. Means there should be no friction on the surface. Now, in our real life, it is not possible. In our real life, there is a friction, right? There is a friction everywhere. So, what does Newton tells you? So, Newton gives the law that suppose let us assume that you are going abroad, right? You close your cupboard and you put some stuff in it. Let's say your book. Your book is in that drawer, right? Or let's say your favorite cricket bat is in it at some one corner. So you put it there and you're going to come after a month. So is your bat is going to move from one place to another without anybody's effort, right? So it is going to be at that place only. So what did it say? An object what did it say? An object is at rest, will remains at rest, right, until and unless an unbalance or an external force apply on it. Correct? Somebody don't apply force on that object. Do you think that object is going to move? No. Okay, so that's what they said. An object is at rest. An object is at rest, will remains at rest, right? So I give you an example also. Whatever you put at one place, suppose before sleeping you put an object at one place, you wake up, will that object move? No, that object will not move on its own. Definitely if somebody have push or somebody have given some force on it, definitely it will move. So an object is at rest, will remains at rest until and unless an external force apply on it. So there must be some force apply on it, then only it is going to move. Second thing, our earth, right? We all know the earth is revolving around the sun. Now the object is in motion. Is it going to stop anytime? No. Why is it so? Why our earth is not going to stop? Right? Because in space there is no friction. Exactly. Suppose I take you to the space, any one of you, and I push you. So how the amount of force I have pushing you, that the velocity which you have achieved, you are going to move with that velocity forever in your life. Yes, you will be a Superman. Right? So you are going to move until and unless you hold some object or somebody gets struck with you, then and then only you are going to stop. Otherwise you are not going to stop. You must have seen Mission Mangal. The satellite which is going over there, they have reversed the friction, thrust, fire, then it has reduced its speed. So in space there is no friction, right? So that is the reason it is not going to stop. Okay, then So Newton has considered both the things. So he said if an object is at rest or in motion, right, remains at rest or in motion until and unless an unbalanced external force act on it, right. So this is what Newton tells you. So what did it say? Simply he considered Galileo's concept also, is actually he inspired from the Galileo's concept, and this is Newton's first law of motion, right, Newton's first law of motion. Okay, again I repeat. So in short, what it is very simple. The object is at rest, forever it is going to be at rest, or the object which is moving or in motion will keep on moving with the same speed or in motion until and unless an external force act on it, right, simple. So this is Newton's first law of motion, and it is all overly accepted. Here I have marked it. See, these three laws of motions are known as Newton's law of motion. The first law of motion, the statement which I gave, you can consider that statement also. The statement which is in the book, you can write that statement also. Both are correct. Have a look. An object remains in state of rest or in uniform motion. Can you see here? In a straight line unless compelled to change that state by an applied force. Okay. So this is how Newton's first law of motion come into consideration, right. It is very simple and very easy. In short, the rest object will remains at rest, the motion object will remains in motion. Okay. This law is also known, right, Newton's first law of motion. So actually Newton's first law of motions are giving you the definition of force. Simple. We are talking here only about force also, that when you apply force on a moving object, it comes to rest, or a rest object, it comes in motion. So basically Newton's first law, what does it gives you? Definition of force. Simple words, right. Okay, so this is the first thing. Tomorrow we are going to see two things. One is inertia and Newton's second law of motion. Very interesting. Both are very interesting. Okay. Fine. Till then, take care. Have a good day. We'll see you tomorrow. And if you have any doubt, please ask me. Thank you.